So I'm Stephen Foskett, and this is the last panel session. We're going to be talking about engineering storage for virtualization and cloud. I came up with these topics after talking to the representatives of the companies that we're going to present and talking to the field day delegates and just sort of knowing what's going on in the industry. And I personally feel that virtualization changes everything. And we've seen a picture of a blender. We've seen, some really remarkable graphs of I/O performance versus capacity. Virtualization is driving a lot of, from the scale-out topic, from solid-state topic. And my question for you all, I know that all of you are working on solutions. Well, 4 of you are working on solutions for storage for virtualization, storage for cloud. And then we have Mr. Preston joining us at the end.
Solutions.
He's working on some kinds of solutions. So I'm interested, how do you do this? How do you build storage that is appropriate for use in server virtualization environments? And I think we'll start with, on the introduction side, we can start right here with Tom.
Sure. So my name is Tom Isakovich. I'm the founder and CEO with Nimbus Data. We are a leading developer of multi-protocol flash memory storage systems. Our approach on how we architect systems for virtualization is quite simple. We need to engineer those systems so that they have a significant amount of bandwidth between the actual flash memory capacity and the network to which you're feeding it. You've got to deliver that, otherwise you're not really going to solve much of the I/O blender problem just by slotting SSDs into the same old servers or JBOD devices. You actually have to engineer the hardware for flash. I think the second thing we're doing is we're making our device eminently flexible and simple. There's some contention about what's the best way to deliver storage into a virtualized environment. Is it using block storage like iSCSI or Fiber Channel or IP over IB with iSCSI? Or is it file-based storage like NFS? Each has their pros and cons. Nimbus from day one has always been about multi-protocol, meaning we support block and file storage protocols natively, simultaneously, letting customers decide what they want to do. Then, of course, finally, you've got to integrate with the hypervisors at the API layer. I think that's obviously an essential requirement. And that means supporting hardware offloaded cloning, ATS, other features that allow for the virtualized environment to queue up I/O correctly to a high-performance shared storage system. There's many more things, but those are perhaps the top 3.
I think you just scooped a lot of the other guys, too. So.
Oh, okay, sorry.
All right.
I'm Matt Kixmoeller, head of product management, product marketing for Pure Storage. We're an all-flash array vendor as well. And I think when we started, the initial realization we had was that the first generation of flash mostly just didn't work with virtualization. If you look at the first generation of flash, it was focused on big databases, and there was not, in a lot of cases, HA. Good luck trying to mirror a storage device underneath VMFS. It's just not possible. And so, by and large, what people who want to implement virtualization over storage devices need is something that actually looks like a traditional array. And so we started out with that kind of design, if you will. And I think, as Tom said, really understanding your customer here is important. And when we started, we basically said, at the end of the day, if you look at the trajectory of IT environments, it's going to be harder to find non-virtualized environments than virtualized. And so in this generation, you start virtual first. You build your development process with virtualization, you build your test process with virtualization, and you basically bake that into your entire development process as a company from day one. And you just start with that feature set in mind, and it becomes your primary goal. And so total integration with the stack from the virtualization vendors, total testing, making sure you're on the VMware HCL and all the other vendors' HCLs, and just thinking virtual first in basically everything you do.
Hi, I'm Dave Wright. I'm the founder and CEO of SolidFire. We build a scale-out all-solid-state storage system for large cloud environments. So I think that's an interesting question because both virtualization and cloud was mentioned. A lot of times those two things are used interchangeably, but I don't think they really are. And in reality, virtualization certainly puts a lot of pressure on storage systems, but I think there's a number of storage systems available today or being developed today that are good solutions to some of the challenges of virtualization. Challenges like I/O density, the VM blender, and all of that. When you talk about cloud, you've got all of those problems, but then there's a whole nother set of problems that come with cloud. Problems like scale, going from a 32-node VMware cluster to a 32,000 core cloud data center. Challenges like multi-tenancy and the fact that, look, this isn't a a business's kind of set of virtual machines, I've potentially got many, many business units. I've potentially got many, many customers in this cloud environment that are sharing a common set of infrastructure. And I've got to deal with the security concerns around that, the performance concerns around that, all of those types of issues. Automation becomes essential at cloud. It's nice to have automation in a virtualized environment, but most people today get away with using the VMware UI and the VMware tools, and there really isn't a whole lot of large-scale automation being done. But when you get into cloud environments, automation becomes critical. So when you talk about building a storage system for a cloud environment, as opposed to a virtualized environment, you've got to solve all the virtualization problems, but you've also got to solve all of those other issues as well.
Hi, I'm Rajesh Nair. I'm the CTO and founder of Tegile Systems. And unlike the other set of panelists here, we are the only ones that make the hybrid storage. The rest of the folks here are all flash arrays. And really, how do you design storage for virtualization? On the storage aspects of it, none of the things are very different, right? You've got to store the data persistently, reliably. You've got to be able to back it up. You've got to be able to snapshot it, replicate it. All those storage functions remain the same as any other storage array. But really the question is, how do you meet the challenges of virtualization? That taking a bunch of applications that are not really meant to live together, you certainly put them on a host or a set of hosts that are in a cluster, and they're all addressing the same storage array. And it's really a question of addressing that sudden burst of random I/O efficiently, and also, trying to make sense of locality of data and the temporal nature of data, and how best you leverage your cache and faster media in order to be able to keep up with the demands of a virtualization environment. And some of it has to do with integration with hypervisors, with storage API, but a lot of it also has to do with how well you can understand the I/O patterns and move data appropriately into cache, and manage your metadata efficiently to make sure that you store data in the right places.
W. Curtis Preston, founder and CEO of Truth in IT, publisher of BackupCentral.com and TrueBit.tv. I'm Mr. Backup, so when we talk about virtualization, the only thing I'm going to care about is whether or not we can back it up, and when we do our seminars and we poll the audience, still this significant percentage, the majority of the audience members in our seminars still say that they do it the old way, which is run it in a backup agent in the VM, which I think the technical term for that is that sucks. And so when I look at a new exciting storage system designed for virtualization, the only thing I want to know is whether or not they even considered, I'm glad, you said, well, you've got to do these things that all those things you mentioned. Well, not everybody does those things, right? And so that's what I look for when I look for, designing stuff for virtualization, whether or not they considered that part of the, or if it's yet another, oh, great, I still get stuck in running an agent in the VM, because that's no fun at all.
I like putting
Yes.
a ringer into things like this, because it kind of shakes things up and reminds you that there's more to the story than maybe what we are going to talk about. So Curtis is going to try to keep us all honest with a little bit of outside perspective here. Dave made a great point. Virtualization is not cloud. And I think that it's important for everybody to hold hands and sing out loud that that's true. We do hear a lot of cloud washing, where people say it's a server virtualization solution is synonymous with cloud. Another one of the things that Dave mentioned that I totally agree with is that one of the core requirements of something to actually be called cloud is automatability or automation. An API, basically, a cloud is like it's like a server, right? It's something that does work on behalf of other machines, not on behalf of people, really. And the machines need to be able to reconfigure it. Virtualization, honestly, has a lot of things in common with the cloud, though, in that you have automation and integration and scale. in both cases, what we're looking at is a unique workload that is very different from the traditional physical workload that all of this stuff evolved from. I always get a big reaction whenever I'm speaking at my seminars when I compare the old I/O path, the predictable I/O path, with this new virtual I/O path. And in both cases, whether it's a cloud workload, a platform, or whether it's a hypervisor workload, you've got systems, storage systems, traditional arrays that are trained and designed to assume that any I/O that comes in on this port is owned not just by this particular server, but even this particular application. And I can just lump that together and make this assumption. That's all out the window now. One of the key things that's come up again and again here, though, is that you have to design systems that can be flexible. How do you do that? How do you maintain compatibility? Virtualization is about compatibility with previous systems. How do you maintain compatibility when, and yet still move things forward? How do you design a system that can continue to function in a virtual world?
So I think, I think there's a couple of key elements there. One is that, you've got to support the storage protocols that are in use today. Unfortunately, we don't have the freedom to develop entirely new protocols to solve some of these issues.
People are doing it every day,
Well, people are trying, but to realistically have a chance to be successful, you've got to work with the limitations of what's there today. But that being said, some protocols are better than others for solving this. So we've chosen to use the iSCSI protocol with our system because it has characteristics that allow it to scale out easier than, say, NFS. And so that's a decision that we've made. But there are solutions on the horizon that may make that easier with PNFS or NFS4, for example, on that side. So that's part of it. The other part of it is this is an evolving ecosystem. It's not just the storage system that's changing. The hypervisors, the storage management in the hypervisors is changing as well. If you look at some of the things on VMware's roadmap, a lot of what they're doing is removing some of the legacy limitations about how things were built, and they were built that way on the hypervisor because of limitations on the storage systems. Well, now as storage systems are evolving and are capable of handling thousands of objects or thousands of LUNs or thousands of volumes and handling different attributes and metadata for each of them, well, now VMware and other hypervisors can take advantage of that and remove some of the layers of abstraction that have been built up over time and create a more direct connection so that you lose some of this I/O blender effect, you lose some of the loss of visibility that we have today. If you look at some of the layering that's in effect in the virtualization path today, I mean, it's almost laughable how ridiculous it is. You have operating system file systems on top of virtual block devices, on top of essentially a NFS protocol, which is a file-based protocol, which is then going to a storage system, which is putting that on top of physical block-based storage. We're going through 4 or 5 different translation layers to make that a single I/O happen. And that's just not necessary. And so, we can't go from A to Z because we don't own the whole stack. But what we can do is work within the limitations of the storage protocols, the virtualization, the hypervisors that are there today, solve a lot of these issues, but then work in tandem with the rest of the industry to push the protocols forward to remove some of this kind of underlying cruft that is causing a lot of the complexity and issues.
Yeah, I agree with Dave on the cruft in the sense that I think as people have just seen virtualization work on top of storage, it becomes obvious to people that the right architecture is VMs visible at the storage tier. So then you can understand them, you can snapshot them, you can replicate them, you can manage their performance, et cetera. And if the problem though becomes that you were looking for a world where it gets easier and more seamless across, from what I've seen, the different virtualization architectures are actually taking very different paths to solving that problem. Some of them proprietary, some of them a little less standard than others, et cetera. So I think the road over the next few years is going to be a lot of work to keep supporting the normal stuff, and then a few interesting flavors on a per platform basis that'll actually make our lives as vendors harder, not easier in some ways.
Yeah, it's not going to be harder on us. It will be better over time, though.
Yeah,
Hopefully,
I think just to add one point here, I completely agree with you in that protocols are there: fiber channel, iSCSI, NFS. So I mean, these are the standard set of storage protocols that one kind of needs to support in order to integrate into any enterprise environment, and that's unavoidable. You have to do it. But there are some things you can change. Curtis mentioned earlier that backup. That's an important question. If you have I don't know, 60, 100, you name the number, terabytes of storage for your, even a mid-range virtualization environment. What are you going to do? Are you going to copy this off to tape every night? That's impossible. So you have to look at alternate mechanisms for enabling backup or data protection. How do you do that? Can you work with snapshots? Can you work with incremental snapshots? Can you work with incremental replication? And can you move that to an offsite, a secondary site? So there are things which have to be done differently for virtualization, and backup is one of them, while living in the constraints of all the standard storage protocols that you have to.
What he said.
Yeah.
I think one other interesting point is where is the dividing line between the data management functionality between the hypervisor layer and the storage layer. Historically, the data management functionality has been in the storage array. In some of the older days, we had lots of host-based software, Veritas and so on, that did a lot of the data management functionality. With each new release, VMware sort of continues to broaden its data management capabilities. And I guess a big question on the roadmap for any storage vendor would be, where's that dividing line between how far VMware will go to managing storage assets to the point where they can relegate the endpoints to principally hardware devices that obey the VMware infrastructure? Because if you look at the compute side of it, that's been effectively commoditized. So the network side of it has also been significantly marginalized as far as the differentiation there. A lot of it is now fairly basic. VMware is doing a lot of very intelligent things in the way it manages networks. So where does that leave storage, and what are the key assets that the storage array needs to provide? Because, for example, one area that I think is very interesting is this concept of tiering, and one of the audience members was asking me about this. Well, what about all these arrays that do tiering compared to an all-flash array? Well, our view is that actually it's better to do tiering a little bit higher up in the stack, a little bit closer to the application, potentially actually at the hypervisor layer, where already VMware is doing sort of the basics of this with things like storage DRS. That allows you then to sort of mix and match different storage hardware on the back end and still retain sort of the automation capabilities that the hypervisor layer provides. What's next after that? And could that be around caching? Could it be around the effect of data reduction through more intelligent data management, where data management or data reduction on the array doesn't yield any more the same ratios that it did before, because VMware is doing a better job of more efficiently writing the data to begin with. So these are other areas where I think everyone here is compatible with VMware, but how VMware and all these other hypervisors execute over time should be pretty interesting as far as where the storage vendors continue to differentiate and add value.
Well, it's true. I mean, a basic hard disk drive is compatible with VMware,
right,
and compatible with the cloud too, right? I mean, as long as it's anything that's industry standard. But obviously, VMware, Microsoft, and a lot of the cloud systems are going way beyond that. And actually, I'd like to call out two things in particular: VAAI and ODX, as an attempt. I am so glad to hear Dave describe the layer cake of virtualization platforms. Effectively, you've got, if you look at it closely, you could have a dozen virtualization layers between the application and the disk. And at each layer, you're losing information. It's, I call it a stack of lies, because you have each layer lying to the layer above it in order to maintain compatibility and uniformity. And each layer below it doesn't know, it knows less and less and less until you get to the storage array, you poor folks, who have almost no information about what's going on above you. You just see a stream of data. In order to break through that, VMware noticed that they need some kind of protocol that allows the hypervisor to directly communicate critical information to the array in order to enable, copying, sublun tier, locking, that sort of thing, zeroing. Now Microsoft has ODX with the T10 standard commands as well, and in both cases what you've got is a way to try to cut through that layer cake. How does that affect you in terms of designing these systems?
Well, we've put in the T10 compliance some time ago, so we chose to kind of embrace the standards around that. So we fully support the vStorage API down to all the different levels, atomic test and set, zeroing, write same, hardware offloaded cloning, and so on. But there's even more that's coming after that. We've begun looking.
Yeah, let's get to that in a minute. Yeah, we'll talk. Yeah.
The version 6 stuff gets even more sophisticated. What's in there? So we definitely have to keep up. But we've done it and been shipping it for some time.
One comment I have there, I'd say these APIs were maybe one of the first things that made it clear there was kind of a chink in the armor in traditional arrays. If you look at a lot of these commands, they turned out to be pretty straightforward when you have a highly metadata-based storage system. A lot of them are just 0 set of blocks, and the back-end work on the disk and the geometry impacts are minimal. That wasn't the case for retrofitting a lot of these to traditional storage arrays. And so I think all of us up here have probably had an advantage in the sense that a modern storage array allows for these commands to be implemented very efficiently. And as you look forward into what's coming in the next generation, the same holds true.
Just to add to that, I think to a large extent, it's become one of the check boxes, in a sales process. That it's no longer are you on VMware's HCL. It's also do you support VAI? That's become a checkbox. So I think most storage vendors will support it if they don't already support it. But these are still, if you look at the set of commands, these are still very much SCSI commands. It's an extension of SCSI really to the hypervisor, giving us some visibility into the SCSI commands that it's going to send us. But if you look at VAI for NFS, it's not quite the same beast. It's a very different beast. It has much higher levels of knowledge in there in terms of snapshots, in terms of clones, and things of that nature, which VAI block does not give you. And now I think that's a higher level of intelligence, and that is where the difference between protocols is going to start affecting storage arrays, and how it affects customers in how easy it is to deploy some of these things. And beyond that, as we heard, VMware 6 most likely will have vWall.
Most likely.
Most likely will have vWall, and then
if we knew anything about it, it would, yeah.
Okay, well, it scares me too, but yes, it'll introduce a whole new level of intelligence. I think that'll be exposed to storage arrays.
Yeah, I was just, so do you think that's because your comment about that VAI has different functionality for NFS, you think it's because traditionally people have done more snapshots on filers than they have on block devices, and so VMware just programmed to that sort of behavior pattern?
Yeah, I would actually answer that by saying I think there clearly is a group of partners that VMware caters to initially, and I think that group is expanding over time here. But if you look at how they've built the functionality in and the timing they've built it in, VMware has driven a lot of that, but also it's enabled by what their partners are able to deliver in their systems. And so over time, and with more of these next generation systems available, the scope of what the storage systems are capable of doing I think is going to expand, and you'll get more of these functionalities across the different protocols. Because it's not protocol limitation so much as it is, like you say, storage systems and what the storage systems that use those protocols have been capable of delivering or not.
Yeah, because to go back to my world, right, with VADP, right, I don't even know if there's any integration or plans for integration to be able, I'm a very big fan of snapshot and replication-based protection, but I don't even know if that's even built into the VADP infrastructure for you to be able to do that. I know you can take a snapshot in VMware with VADP and do a regular backup of it, right. But hopefully that will be totally managed as well. That I can do a snapshot-based, replication-based backup that's managed by VMware via VADP, and have all that stuff as well.
I think VADP, you're still going to need the backup applications integration with VADP in order to take advantage of any array functionality with regards to snapshot and replication. But yes, I mean when it comes to VMware, it's not just VAI, it's VADP, it's Virtual Infrastructure API. There is the two different flavors of VAI and so on and so forth. So I think to get a complete storage solution, you kind of have to support all of that and leverage that to a great deal.
Yeah, and so to continue this, where does this go next? Obviously, many of us have heard of, vVol. We've heard, and there again, to me, that's sort of VAI 2, even though it's of course not. It's 6 or whatever. To me, it's sort of the next generation of cutting through the chain of lies.
No, and I think it is. It is. I would even argue the earlier stuff was not really cutting through much of that abstraction. It was offloading certain operations that were more expensive for the host to do than for the array to do. But it wasn't really giving the array any more visibility as to what was actually happening and what the actual intent of the end user or the virtual machine was. The addition of VASA was maybe a start at some of that, but really the array was just giving information to the hypervisor. Yeah. And now we're starting with vvols to have some bidirectional exchange, where now we know which bits belong to virtual machines and what the characteristics of that virtual machine is supposed to be. And now, so we're finally starting to cut through some of these layers and get direct access to that and let the storage array do some of the things that are just better done at the storage array level. That doesn't mean you can't manage it at the hypervisor level, but for the hypervisor to tell the storage array, take a snapshot, replicate a snapshot, clone this volume, whatever it may be, that's a much better model than saying, look, we're gonna move all of that into the hypervisor and make the disk a completely dumb device, which there has been some motion towards. But I think that this is actually a good step in that it's a realization that, look, there are some things that are better done at the hypervisor. There are some things that are better done at the storage system level. As the storage systems become more capable of handling large numbers of volumes, large numbers of metadata entries, large amounts of replications, snapshots, clones, and other things that you need for the density that you get to with virtualization and cloud, great, let's offload that onto the storage systems. Let's put the control plane somewhere else. And when we talk about this move to software-defined storage and a software-defined data center, it's not about moving all of the functionality into the hypervisor or into a software layer that's completely separate from the storage. It's about separating the control of that and the orchestration of that so that you're not going to your storage array tool to take a snapshot. You can actually do it through whatever management you have for your infrastructure, whether it's VMware or OpenStack or something else.
Did we have a question?
Yeah, my question is that this discussion is way too focused on VMware. Ideally, we should figure out a way to do an open flow for storage. And that thing is totally missing from the vernacular, from the overall conversation.
Well, that's a good point. So what?
We're spending a lot of time just going and selling, making money, but nobody's actually saying, let's just build a consortium where we'll have an open flow where VAI is actually a driver as opposed to the de facto standard.
So the question, to repeat the question, instead of just focusing on the VMware implementation, what we need is, as an industry, something bigger that allows this beyond VMware, and so it expands this discussion beyond VMware. I think that's a great point. I'm not sure that OpenFlow is the ideal analog of that, but at least it's
yeah.
The right umbrella organization.
Well, and actually, there is movement in OpenStack right now to do something like that, and something we've been participating very heavily in, which is that it used to be storage was an integral part of the compute project at OpenStack, and the two were linked. You had to use one to get the other. And what's happened in the most recent release that just came out is the storage component, the essentially block storage component of that, which isn't specific to the storage protocol, but how it's exposed to the virtual machine. That component has got broken out into its own project named Cinder that is separate from the core OpenStack compute project. Now the functionality that's in there is still very basic. It's much less than what you'll find in VMware or other kind of storage management stacks today. But now there's a foundation to build on, and a lot of storage vendors, including SolidFire, including NetApp, including Ceph, and other people, are involved in the evolution of that as well as the integration of that into their storage platforms. And as a separate project, we now have something that other cloud management stacks can tap into potentially as the basis of their storage integration. So I don't know if it'll ever end up quite like OpenFlow because it really is at a slightly different level. But as an abstraction layer for managing storage in a cloud-like manner, I think it's a very good start. And so we'll have to see where that goes. But I agree that we can't do this solely through a single closed vendor.
I mean, VMware should be applauded for doing this. I think that it's a travesty that nothing else ever thought of doing array offload.
I think it's also, but I think it's also important to note that VMware, a lot of things they initiated have been pushed into the T10 standardization process, and now other people are able to adopt and use as well.
And Microsoft's taking advantage of that with ODX.
And so hopefully there will be more of that over time. Things that start as proprietary vendor extensions do become standardized, and other platforms can use them.
So,
But you know, agree. But I do believe that you're going to see two very different tracks. One in the public cloud and one in the private cloud or enterprise. Because in the enterprise, given that VMware is the new OS really, and Microsoft has Hyper-V, and you're going to see about as much cooperation as you saw between Microsoft and the Unix vendors of the past. So it is a travesty, agreed. It is high time, agreed. But practically, to see a joint API or a driver model emerging between all these vendors.
yeah, there's a lot of jockeying going on.
There
here.
is.
And a lot of people claiming, we're the open standard of it.
Yeah, I mean, I remember from, gosh, what was it, maybe 10 years ago, the promise was that no one would ever have a vendor-provided management GUI.
Yeah.
It would all be SMIS. We'd have
Indeed.
this, we'd all have wide sky.
Yeah, wide sky.
All this, and it's one of the natures of the storage business. I think you go where the money is, and obviously there's a lot of reasons why things are kept proprietary, and there's something of a cartel in the way storage behaves in that sense. So I'm not holding my breath either, to your point.
But in my mind, it has to happen, because one thing we can't do is just maintain things the way they are with basic SCSI protocol.
Well, I don't think there's anything fundamentally wrong with the SCSI protocol. It's obviously survived for a very long time and is a very flexible, capable protocol. I think there is functionality that's needed in it, and there's functionality that's needed out of band as well to administer the storage system that really has nothing to do with the actual data plane and the data transfer. That's where there's a certain amount of standardization that's lacking. And again, projects like Cinder, which are much more about the control plane, standardizing that, allowing vendors to plug in drivers under that, because there isn't a standard storage system API, SNIS notwithstanding, for them to universally support. A driver model in a project like Cinder allows you to standardize that control plane, provide a heterogeneous or homogeneous set of functionality across a heterogeneous set of infrastructure, and not have to go and put everything in the SCSI protocol, because it doesn't all belong there.
I think if I could reword what you said, we can't continue to do it the way that we're doing it. I'm not sure if that means you're saying we have to have a common method across all the hypervisors. I think you're saying we've got to start managing the storage in a better way, be more, to get rid of the layers of liars. I forgot what the stack of lies. Get rid of a few of the stacks, or
well, I'm just saying cut through the stack.
Yeah, cut through the stack. Yeah. But this is a problem we have everywhere in IT, right? And I think that you're going to have a common API like this between the different virtualization vendors right after TSM and Net Backup swap tapes and can read each other's tapes.
Yeah. Well, there's always a dynamic between openness and
Money.
closedness and money. Yes, openness and money. There you go. We have a question here or comment?
I think SCSI standards are going to continue to evolve because we're going to keep coming up with new ways of making use of SCSI storage. And adding things to T10, I don't think is necessarily a problem. It was a standard that was meant to evolve, and virtualization drove an awful lot of the sharing of storage, and I think that's where you're seeing an awful lot of the changes that have come along. What the requirements is for an awful lot of the changes that have come along.
Yeah, the only thing I want to add to that is that we have to stop looking at things at a LUN level, right? Because we're talking about entities which are higher level, like VMware and VMs and software defined and so on. So it has to be outside the data path protocol. So I agree with Dave with the fact that it's got to be something out of band.
Yeah.
Or with APIs with the entities of high level abstractions.
So to summarize these comments, we've heard that T10 was designed to be scalable, and so it's no surprise that they're scaling it, and that we should look beyond the data path. And again, as Dave said, SCSI works as a way to move data back and forth to a drive, and I want to say disk drive, a drive. do you go beyond that? Do you
Yeah,
go
well,
outside
and
that?
the nice thing is SCSI provides multiple layers of abstractions with targets and LUNs and ports and all of these different things that with an appropriate control path to map those to entities that make sense, like a virtual machine or a tenant or a cluster, or essentially with the knowledge of what those things actually mean, the storage protocol itself is fine. The problem is right now things are layered such that those SCSI entities don't really map to anything meaningful on the other end. And so, the combination of those two things ultimately allow the storage array to do a better job of managing lots and lots of workloads in a cloud or virtualized environment.
So just reality today, right? I mean, you have to look at this as two different problems. One is, yes, SCSI is going to keep evolving. That's a great place. T10 is a great place, and that is going to evolve. There's no two ways about it. And storage vendors, we have to keep adding support for the new commands that come into T10. But if you look at the other protocol in play here, NFS is a reality today, and a lot of people use NFS for virtualization, and it does have a higher intelligence in terms of what the entities are. At a VMDK level, I know that is a virtual list belonging to a particular VM. I have a method and a means of querying that VM and figuring out how many other drives does it have on my array, on other arrays. So you do have a situation where a single unified array like the one we make does provide two different levels of intelligence is able to provide two different levels of intelligence based on whether the access protocol is NFS or the access protocol is fiber channel or iSCSI. And there needs to be some level of unification between those two approaches, because as a customer, it's very difficult to understand why a Tegile array gives me more information when I'm using NFS about VMs and about how many IOPS each VM uses and things like that, as opposed to when I'm using fiber channel. So some level of intelligence does need to move up.
Yeah, that's I think it's very interesting and very telling that so many vendors have turned to NFS for VMware.
Yes.
And I also think it's very interesting that Microsoft has so forcefully lunged into SMB as the storage protocol, not just for Hyper-V, but also for other Windows Server 2012 workloads, whether it's SQL Server or Exchange or anything. And again, the reason I think is because there's just more information.
Well, yeah,
It's a very simple thing.
Fundamentally, though, if you look at what a file system protocol like that is, it's the combination of a data path and a control path, right? The control path being the file system, the metadata operations, the other things you can do with that data path. So the movement to those things is really about a way to have a single protocol that covers both of those things. And the reason that you're seeing that is because the block-based protocols are really just that data path. There's no control path associated with it. There's no standard for that, and there's no way to manage it. So the de facto thing has been, rather than, okay, let's get together and have a standard protocol or standard way to manage these block-based devices, instead we'll just hack onto these other protocols that effectively have control and data information in the same protocol, and we'll just have a structure for how we lay out directories and a structure for how we lay out our files and how we name files, and the storage system may be able to infer certain things from that. I'm not saying that's the right answer, that's an answer, but I think, and I certainly hope that over time, block-based virtual machines can use block-based protocols, cut out a bunch of those layers, and then there can be control planes, whether they're proprietary control planes like VMware or open control planes like what's being built as part of OpenStack, so that the storage protocol doesn't become a limiting factor in what you can do with that storage system.
Well, I think it's time to do a little summary.
Quick comment on that.
Yeah.
Yes, the file system certainly owns an awful lot of that, which is why with NFS or SMB, you see the file-based management. My quick question was going to be about scalability. Based on the fact that you're actually using block storage in this case, there are some options for you to increase your scalability, both using intelligent multi-pathing and using host-based plugins that certainly are not there for NFS. Are any of you looking at the intelligent multi-pathing or optimizing having to use multiple paths between the hosting and storage?
So the question is, block protocols give you the option of using intelligent multipathing and host-based plugins to improve scalability, and are you doing that?
Yeah, and just today we're not doing that. We're doing intelligent distribution of connections across the scale-out storage system to balance the load. But for an individual connection, we're not worried about that scalability yet. Again, the movement of having more intelligence about the individual virtual machines and which virtual machines are on which connections and other things allows us to do more of that. Obviously, it's better to avoid host-based plugins where you can do that. Protocols such as PNFS, or NFS v4, I should say, are actually really nice because although it's historically been a file-based protocol, it now has block and object flavors essentially as part of it as well. And actually, the capabilities of that protocol go far beyond what is natively, for example, in iSCSI or Fiber Channel when it comes to being able to do essentially distribution of data and essentially host-based routing of data to different endpoints than, for example, what iSCSI has. And so I really do think that the evolution of storage protocols on the data plane there, not even looking at the control plane capabilities there, but the data plane capabilities without having to build host-based plugins, with actually having it standardized as part of the protocol, will make the job of being able to scale the individual I/O for a volume or a set of volumes a lot easier. So there's a certain amount we can do today, and I'm sure we'll be doing more in the future.
I'll chime in on the not really liking the idea of host-based plugins also. It's just a hard model for a vendor to really invest in long term. It's a bit easier on iSCSI than it is in Fiber Channel today, and I think if you look at a lot of the current generation arrays where you've got 4, 8, 16 ports, it's not so bad to have them all open to a number of hosts, but as you look towards broader and broader scale out where you're up to port counts that are much higher than that, that obviously breaks down. And so, I can't really talk much about what we're doing to solve that, but it's something that everybody has to solve.
As far as Nimbus is concerned, we're a flash array that supports NFS natively. So, customers that are looking for kind of putting that file system responsibility onto the array, we simply allow them to do that with NFS, while at the same time supporting block protocols as well. And our customer base is almost 50-50 religiously divided between what they do in their VMware environments. One of our very large customers, which is eBay, runs hundreds of terabytes on NFS, while another division within the very same company runs hundreds of terabytes on iSCSI. So I think supporting both is a good idea.
Well, let's wrap up. If you guys have a bit of a closing statement, you want to start here, Tom?
Sure. Well, at Nimbus Data, we are really helping, I think, accelerate the adoption of Flash into enterprise use cases. And I was very excited to be part of this panel, and look forward to being part of Tech Field Day tomorrow. And thanks for staying for the full day.
Yeah, thank you.
I'd say for us at Pure Storage, we've seen the biggest adoption of our storage around virtualization on almost the opposite side of the spectrum of where a lot of this conversation has been, towards smaller users. And I think the reason for that is that smaller users don't have a performance problem until they go to virtualization in a lot of cases. And they're just kind of hit over the head for the first time with actually having to worry about storage. And in those situations, it's often a person who doesn't have a storage team. He is the storage team and the VM admin. And so we've actually spent a lot of our time, of course, worrying about larger deployments, but really being focused on that kind of bite-sized VMware deployment that might be tens, hundreds of terabytes, and just making that a completely integrated user experience.
So I think for my part, we've talked about a lot of the challenges that are intrinsic in virtualization, some of the things that are being done by the different vendors up here to solve them. I think if you have virtualization storage problems, the good news is that there are a lot of people that have solutions today. If you are building a cloud, however, please come talk to SolidFire, because I think we have a very unique approach to solving some of these problems that go beyond what a basic virtualization has to deal with.
Just want to close with saying that at Tegile, we primarily work on creating hybrid storage solutions that really make the best use of flash as well as capacity drives to give a customer the best performance and capacity at the same time. And you can only do this, do $1 a gigabyte at the IOPS that most mid-tier, medium-tier to large-tier applications need by going this hybrid route. And thanks, Stephen, for arranging this, and thank you guys for staying all day.
I'm just going to say I'm the only person up here who's never shipped an array with a bug. in it.
Congratulations, Curtis.
Thank you very much, Curtis. I appreciate that. Well, with that being said, let's clear this out. Thank you guys very much for joining me. This has been a great discussion.